Okay, we got a question from 2007. It's a by hand question. As you can see, what we're trying to do is graph the derivative function on the same set of axes. So that's what we need to do. So let's have a look at that. We need to let's take a look first of all at where the gradient is equal to 0 on the original graph. So what we want to do there is we want to graph a 0 gradient. So let's just show you that one. But at x equals 3, the gradient doesn't, or the graph doesn't exist. So, or is not continuous. So what we're going to do at x equals 3, we'll put an open circle, but then the gradient is 0 all the way along there. The other part of the graph is a straight line, and this gradient is positive, and it's also constant. So what we need to do is graph a positive constant gradient function. So let's do that. And so you can pick anywhere to start the graph on the y-axis, it doesn't matter. But when we get to x equals 3, it's going to be it's actually going to be a closed circle this time, because you can see on the original function the graph did exist. Just looking at this graph as well, at x equals 0, you can see here we've got a cusp, which means there's no gradient function. So on our graph for our gradient function, we need to have an open circle at x equals 0 to say that the gradient function doesn't exist. Next part of the graph is a parabola. You'll notice that at x equals minus 3, the gradient is 0. So what we can do, we can say, well, we're going to go through x equals minus 3, 0 gradient. Prior to x equals minus 3, we've got a positive gradient. It actually starts off more positive. So what we'll do on our gradient graph, we'll graph a positive gradient function that's getting less positive. So it's going to come down this way and keep going. Goes through that point, and after x equals minus 3, the graph is, or the gradient of the graph is negative and getting more negative. Okay, so that's basically just following that straight line down, and just continue that straight line down, and should be a straight line. There we go. When we get to the vertical axis again, the gradient doesn't exist, so we have an open circle. That's our gradient function drawn on the same set of axes. Just for the remaining part of the question, write down the domain of the derivative function. So the domain is all real values except for the gradient function doesn't exist at 0 and it doesn't exist at 3. So they're the points where it doesn't exist. And that should be sufficient to get full marks.